look at a belt-driven idler pulley system, right? You would normally find your head pulley and then your tail pulley, so your tail and your head pulley, as well as a bunch of idler pulleys in between, right? You would have to obviously have your head pulley be driven by normally a reduction gearbox, and then driving gearbox now will then be your three-phase induction motor on the output of a VFD, right? So this VFD you can control with a PLC. But bottom line is, how strong does your motor have to be to pull this head if your belt is stacked with a 5 kilogram per meter longitudinally now of the belt, and it's 10 meters long? Right, so stacked with 5 kilograms per meter and it's 10 meters long, say, so we know that our net weight that will be on the belt will be around 500 kilograms, right? 5 times 10. So let's go and take a look at how we would calculate that with an angle of, say, 20 degrees in this case. Our conveyor's at a 20-degree angle. How we would calculate our basic motor size. So let's go again from first principles. We know for a fact that there is 500 kilograms that has to be pulled up an incline of 20 degrees. Right, so it's going to be pulled up here. How much power do we need? So we go look at the equation. Force is equal to mass, which is 500, multiplied by the gravitational constant 9.81, multiplied by sine 20. And after you've done this, around 1677 newtons of force will be required to at least keep the belt from reversing, right? This is the gravitational force inflicted by the 500 kilogram being at a 20-degree angle. So if you go anywhere over this without friction, you should be pulling it in a direction with velocity, right? So say we wanted a velocity of 0.5. We know that force times velocity equals power. So let's go 1677 multiplied by, say, a belt velocity of 0.5 meters per second will equate to around 0.84 kilowatt, right, of power that we would require without losses now, right? So we haven't calculated what the friction losses are going to be and stuff like that. This is in a perfect system that just doesn't exist. So if you want to play it safe in a ballpark figure, you can double this in this case. You can look about a 1.5 kilowatt motor in this case, right, after you add losses. But if someone had to ask you how you would calculate like a general thumbsuck for the size of a motor of a conveyor, you can just ask him about the weight and the angle, and you can try to determine it with just adding a little bit more fat for friction, right?